Alright, so we are on the Mathematics Higher Level Paper 2 for August 2020 in the Khomas region. As Paper 2, the higher level paper. So let's get into it. We'll do questions 1 and 2 in this video. As you can see, some things are already filled in because I already recorded this, but for some reason the files seem to have been corrupted or cannot be found. So I'm just going to do the ones that I couldn't find over again, but some of the others are already uploaded onto YouTube. Okay, question 1. A function f is such that f of x equals this. We have that function. But now given that f of x can also be written in this form, find the values of a, b, c, and r. So all we want to do here, pretty straightforward, is we just want to equate the coefficients. So let's write down this function on the left here. So that'll be 6x cubed minus 7x squared minus 28x plus 20. And we want to equate that to this equation, this function. So let's multiply this out. So ax squared times x, that gives us ax cubed. Ax squared times 1 is just ax squared. So bx times x is bx squared. And bx times 1 is bx. And then we've got the c to go. So c times x is cx. And c times 1 is 1. I mean c. c times 1 is c, sorry. And then we add the r at the end. Okay, so let's combine our like terms. All the x cubes, the only x cubed term we have is the ax cubed. Then we've got these two for x squared. So we can take out an x squared and we have left the a plus b. So a plus bx squared. And then we can do the same for the x's. So we can say that is the same as b plus c x. And our constant term is just c plus r. Great. So all we need to do now is combine or equate the coefficients of x cubes with coefficients of the x squareds, etc. So for the x cubes, we have over here 6, and that must be equal to the x cubed coefficient here, which is a. Oh, perfect. So we already have the value for a. So that is 6. And then we can look at the x squareds. So here we have for x squared, we've got negative 7 is the coefficient there. And the coefficient over here is a plus b. A plus b. But we already know what a is, so we've got negative 7 equals a, which is 6 plus b. And then we can just take over the 6 to the other side, subtract 6, so negative 7 minus 6 is negative 13. And all that's left on the right hand side is the b. So b is negative 13. Great, and then we can look at the x to the power 1s, just the x's. So here we have negative 28 as a coefficient on the left. And on the right, we've got b plus c. So equals b plus c. And again, we already know what b is, so we can just substitute that in. So b is negative 13, and then plus c. So then we can say let's add 13 to both sides. So negative 28 plus 13 is negative 15, and all that's left on the right is the c. So that's our value for c. And then finally we can do the constants, the x to the power 0 terms. So that would be a 20 on the left. And on the right, we've got c plus r. c plus r. And what do you know? We already know the c value as well. So we can substitute that in. The c is negative 15, and then we've got our plus r. So finally, we can say let's add 15 to both sides. So 20 plus 15 is 35. And on the right, we've just got an r. So that is our value for r. Okay, great. So it's a lot of writing, but not a lot of thinking here. All we do is multiply out and equate our coefficients. Question B. Show that x plus 2 is a factor of f of x. Okay, let me just write down the function f of x before I forget that. So f of x, we said that is 6x cubed minus 7x squared minus 28x plus 20. Okay, we need to show that x plus 2 is a factor. So to see what we have to substitute in here, let's put this equal to 0. So x plus 2 equals 0, which means x must be equal to negative 2. So by the remainder theorem, if we have f of negative 2, if this answer equals 0, then this is a factor. So let's check what we get. So 6 times negative 2 cubed minus 7 times negative 2 squared minus 28 times negative 2 plus 20. And let's work that out. Okay, so negative 2 cubed is negative 8. Negative 8 times 6 is negative 48. Negative 2 squared is 4. 4 times negative 7 is negative 28. Negative 28 times negative 2 is positive 56. And we have a plus 20 at the end. So that gives us negative 76 plus 76, which equals 0. So there we have it. Since f of negative 2 equals 0, then we know x plus 2 is a factor. Okay, hence factorize f of x completely. Okay, so I'm going to do long division for this one. You're welcome to do synthetic. Maybe I'll do both. Let's do both. Okay, so I'm going to start with long division. So I'm going to write down the function 6x cubed minus 7x squared minus 28x plus 20, and we're going to divide that by x plus 2 to get our other factor, since we know this is already a factor. Okay, for long division, let's start the process. So the first term here, 6x cubed divided by the first term there. So 6x cubed divided by x is 6x squared. And then we multiply this answer by the whole factor in front. So 6x squared times x is 6x cubed. And 6x squared times 2 is 12x squared. Okay, and then we want to subtract this. So the algorithm works the same as if we were just doing with numbers instead of with algebra and letters. Works exactly the same. The 6x cubed minus 6x cubed is nothing. And then negative 7x squared minus 12x squared is negative 19x squared. And then we want to bring down the negative 28x. And then we just repeat the process. So negative 19x squared divided by x is negative 19x. And we multiply this by the whole factor again. So negative 19x times x is negative 19x squared. Negative 19x times 2 is negative 38x. And again, we're going to subtract this. Let's scroll down a bit. So negative 19 minus minus 19 is nothing. Negative 28 minus minus, that becomes a plus. So negative 28 plus 38 is 10x. And then we bring down the 20. And we repeat the process. So 10x divided by x is 10. And then we multiply the 10 by the whole factor again. So 10 times x is 10x. And 10 times 2 is 20. And again we subtract. And in this case, 10x minus 10x is nothing. 20 minus 20 is also nothing. Good. So now we have two factors. So we have the x plus 2. And we have the 6x squared minus 19x plus 10. Sorry, I almost wrote 20. Plus 10. Okay, so now we just need to see, can this part factorize further? And indeed it can. So we've got our first term is x plus 2. And now this will turn into two brackets. And what we can do is, I'm not going to go through the whole process of how to factorize a quadratic. I'm pretty sure we all know how to do that. And there are a couple of different methods to that. So I'm just sort of going to wing this one and check factors of 6, 2 and 3 and 2 and 5. Yes, that should work because we need 19. So 4 and a 15 can get us 19. So I'm going to say that's 2x and 3x. And to get a 4, we can say 2x minus 2. That'll give us negative 4x. And 3x and a negative 5 here. That gives us negative 15. So minus 4 is negative 19x. Perfect. So that is our answer. Let me just rewrite that in the answer spot provided. 2x minus 5 and 3x minus 2. And that is fully factorized into linear factors. Good. Question 2. So here we want to integrate this function. Okay, so first I'm just going to rewrite it as the integral of 2, and then I'm going to take this whole thing to the top. So we have 3 minus x, and instead of to the power half, because it moved to the top, we'll have negative a half. Okay, dx. And then I'm going to integrate using the chain rule. So the chain rule, or in general, if we have ax to the power n, if we want to integrate that, with respect to x, we're going to say add 1 to the exponent and divide by the new exponent. Now if we had a chain rule, then we do the same thing, we just add a step or two. So the chain rule would be, we've got some function, so f of x, a whole function here, raised to a power. So we apply the same rule if we want to integrate that with respect to x. We just rewrite the thing, f of x, and then we add 1 to the exponent, divide by the new exponent, but then we also divide by, so multiply at the bottom is the same thing, by the derivative of this, right? By the derivative of that bracket. So that's the only part that we add in. We add the derivative of the bracket inside here. Okay, so let's start. So we rewrite everything, 3 minus x, and now we add 1 to the exponent, so negative a half plus 1 is positive half. And then we divide by that new exponent, but we also divide by the derivative of the bracket. So 3 minus x, oh, that almost looks like a 3x. I'm just going to rewrite that a little bit because that looks way too dodgy here. So 3 minus x. Okay, so if we differentiate 3 minus x, we get negative 1. And then we just want to simplify that a little bit. So the bottom part here, this whole thing is just negative half. So if we take 2 divided by negative half, we get negative 4. And then we have 3, that 3 is too ugly, 3 minus x to the power half. Good, and that is it. You could also write it in root form if you like. So negative 4, and then instead of the 3 minus x to the power half, you could write that's the square root of 3 minus x. That's also fine. Perfect, and then we need to remember to put our plus c, right? Plus c. Okay, so that is it for questions 1 and 2, and I will do, there's a couple that I have to redo. Question 3, 4, yeah, 3 and 4 I think I have to redo as well. Okay, I'll see you shortly for those ones.